a boy who wondered. On a quiet spring day in March 1879, in the small German town of Ulm, a baby boy was born who would one day change how we understand the universe. His name was Albert Einstein, but when he came into the world, nobody knew that this child would become one of the most famous scientists in history. He was just a baby, like any other, with curious eyes and tiny hands. Albert's father, Hermann Einstein, was a salesman and engineer. He wasn't rich, but he was hardworking and kind. Albert's mother, Pauline, loved music deeply. She played the piano beautifully, and the sound of melodies often filled their home. This love for music would stay with Albert his whole life. Even when he became a great scientist, he would pick up his violin and play to clear his mind and find peace. When Albert was very young, something interesting happened. He didn't speak much. While other children his age were chattering away, little Albert remained mostly quiet. His parents worried. Was something wrong? But Albert wasn't silent because he couldn't speak. He was silent because he was thinking. He was watching the world around him, noticing things, wondering about things. One day, when Albert was about 4 or 5 years old, his father showed him something that would spark a flame in his young mind. It was a simple compass. Hermann placed the small device in Albert's hand. The boy stared at it, mesmerized. No matter which way he turned the compass, the needle always pointed north. Always, without fail. To most children, this might have been just a toy, but to Albert it was magic. He couldn't see any strings. He couldn't see anyone pushing the needle. So why did it move? What invisible force was guiding it? This question burned in his mind. It was one of the first times young Albert realized that the world was full of hidden mysteries, invisible forces that made things happen in ways we couldn't immediately see. This moment with the compass was important. It planted a seed in Albert's heart, a seed of curiosity that would grow throughout his entire life. He began to understand that the universe had secrets, and he wanted to discover them. The struggles of school. When Albert started school, many people expected great things from him. After all, he was clearly a thoughtful child. But school didn't go the way anyone expected. In fact, Albert struggled. He didn't like the strict rules of German schools in those days. Teachers wanted students to memorize facts and repeat them exactly. They didn't want questions. They didn't want creativity. They wanted obedience. But Albert's mind didn't work that way. He wanted to understand why things were true, not just memorize them. He wanted to ask questions, to explore, to imagine. When teachers told him facts without explaining the reasons behind them, he felt frustrated. He felt trapped. Some teachers thought Albert was slow. Some thought he was difficult. One teacher even told him that he would never amount to anything. Can you imagine? The person who would later revolutionize physics was told he was a failure in school. It just goes to show that schools don't always recognize genius, especially when that genius thinks differently from others. But Albert had a gift that school couldn't measure. He had imagination. While other students were busy memorizing dates and formulas, Albert was daydreaming about light and space and time. He would ask himself strange questions like, what would it be like to ride on a beam of light? Most people would think this was a silly question. But for Albert, these imaginative journeys were how he understood the universe. At home, things were different. Albert's uncle, Jacob, was an engineer, and he introduced Albert to mathematics. Unlike the boring drills at school, Uncle Jacob made math feel like a game, like a puzzle to solve. He showed Albert that mathematics was a language, a beautiful language that could describe the patterns and secrets of nature. Albert fell in love with mathematics. He started teaching himself, reading books far beyond his grade level. By the time he was 12 years old, he had already mastered geometry on his own. He didn't need a teacher to force him. His curiosity was enough. Music also became important to Albert during these years. His mother had given him violin lessons, and at first he didn't enjoy them much. But as he grew older, he discovered that music was another language, another way to understand beauty and harmony. Playing the violin became his escape, his way to think and relax. Throughout his life, whenever he felt stuck on a problem, he would pick up his violin and play. Somehow, the music would clear his mind, and the answers would come. A family on the move. When Albert was 15, his family's business failed. His father decided to move to Italy to start fresh, hoping for better opportunities there. But there was a problem. Albert was still in school in Germany, and his parents wanted him to stay and finish his education. So Albert was left behind in Munich, living with relatives, attending a school he didn't like, in a place that felt cold and unwelcoming without his family. He was lonely. He was unhappy. The strict German school system felt like a prison to his free-thinking mind. Albert made a bold decision. He would leave. He convinced a doctor to write a note saying he was having a nervous breakdown and needed to leave school for health reasons. It wasn't entirely untrue. The school environment was making him miserable. With this note, he left Germany and joined his family in Italy. When he arrived in Italy, everything changed. He felt free. The Italian culture was warmer, more open, more relaxed than what he had known in Germany. He spent time hiking in the mountains, thinking, dreaming, exploring ideas in his mind. These were happy months for Albert. But he knew he couldn't just wander forever. He needed education. He needed a future. Albert decided to apply to the Swiss Federal Polytechnic in Zurich, Switzerland. This was one of the best technical schools in Europe. There was just one problem. Albert was only 16, younger than most applicants, and he hadn't finished high school. Still, he was confident in his abilities, especially in mathematics and physics. He took the entrance exam. The results were mixed. In mathematics and physics, he scored brilliantly. But in other subjects, languages, biology, literature, he didn't do as well. The school rejected him. It was a crushing blow. But the director of the school saw something special in this young man. He told Albert to finish high school and then reapply. So Albert enrolled in a school in Aarau, Switzerland, a small town with a much more progressive approach to education than what he had experienced in Germany. At Aarau, Albert blossomed. The teachers encouraged independent thinking. They welcomed questions. They treated students with respect. Albert thrived. He lived with a kind family, made friends, and spent his time thinking about the mysteries of physics. It was during this time that he imagined one of his most famous thought experiments. What would you see if you could travel alongside a beam of light? The patent office years. At the age of 17, Albert returned to the Polytechnic in Zurich and was accepted. He was excited. Finally, he would study physics at a high level. But even at the Polytechnic, Albert remained true to himself. He skipped lectures that bored him. He didn't always follow the curriculum. Instead, he spent his time in the library, reading the works of great physicists, teaching himself the theories that fascinated him. His professors noticed his independent streak. Some admired it. Others found it frustrating. One professor, in particular, didn't like Albert's casual attitude. This would cause problems later. During his time at the Polytechnic, Albert met a young woman named Mileva Merrick. She was one of the few female students studying physics, and she was brilliant. Albert and Mileva fell in love. They studied together, discussed ideas together, challenged each other. Mileva understood Albert's mind in ways few others did. After graduating in 1900, Albert expected to get a job as a university assistant, which was the typical path for someone with his qualifications. But that job never came. Remember that professor who didn't like Albert's independent attitude? He didn't give Albert good recommendations. Without those recommendations, no university would hire him. Albert was devastated. Here he was, a graduate in physics, and he couldn't find work in his field. He took odd jobs, tutoring students, doing temporary teaching work, but nothing stable. He struggled financially. He and Mileva wanted to get married, but how could they without a steady income? During this difficult period, Mileva became pregnant. In those days, having a child outside of marriage was scandalous. When their daughter Lieserl was born in 1902, the couple kept it secret. What happened to Lieserl remains a mystery even today. Some historians believe she was given up for adoption. Others think she may have died in infancy. Albert rarely spoke of her, and this remains one of the sad, hidden chapters of his life. Finally, in 1902, Albert got a break. Through a friend's father, he was offered a job at the Swiss Patent Office in Bern. It wasn't a university position. It wasn't prestigious. But it was stable work with a decent salary. Albert accepted. His job was to examine patent applications for new inventions and determine whether they would actually work. It required clear thinking and the ability to understand technical descriptions. Albert was good at it. But the best part was that the job wasn't too demanding. He could finish his work efficiently, which left him time to think about physics. The patent office became Albert's secret laboratory. During slow moments, he would pull out his notebooks and work on his own theories. While other clerks chatted or took long breaks, Albert was solving the mysteries of the universe on scraps of paper. In 1903, Albert and Mileva finally married. They were poor, living in a small apartment, but they were together. Soon they had a son, Hans Albert, and life became busier. Still, Albert continued his private research, driven by questions that wouldn't leave him alone. The miracle year. The year 1905 would become known as Albert Einstein's miracle year. In just a few months, while working his regular job at the patent office, Albert wrote 4 scientific papers that would change physics forever. It's hard to overstate how remarkable this was. These weren't just good papers. These were revolutionary ideas that transformed our understanding of reality. The first paper was about light. For a long time, scientists had debated whether light was a wave or a particle. Albert proposed something radical. Light behaves like both. It travels in tiny packets of energy he called photons. This idea helped explain something called the photoelectric effect, why light hitting metal could knock out electrons. This work was so important that it would eventually win him the Nobel Prize. The second paper proved that atoms really exist. It sounds strange to us now, but in 1905, some scientists still doubted whether atoms were real or just a useful idea. Albert studied how tiny particles suspended in liquid move around randomly, a phenomenon called Brownian motion. By analyzing this movement mathematically, he showed that atoms must be real, and he even calculated their approximate size. The third and fourth papers were about something that would make Albert Einstein a household name: the theory of relativity. Let me try to explain relativity in a simple way. Imagine you're on a train moving smoothly at a constant speed. If you toss a ball up and catch it, the ball goes straight up and down from your perspective, right? But someone standing outside the train watching you would see the ball move in a curve because the train and you are moving forward while the ball goes up and down. Who's right? Both of you are. This is the key insight: motion is relative. There's no absolute stillness in the universe. Everything is moving relative to something else. But Albert went further. He said that the speed of light is special. Unlike a ball or a train, light always travels at the same speed, about 186,000 miles per second, no matter how fast you're moving when you measure it. This seems impossible, but experiments proved it was true. If the speed of light never changes, then something else must change. And that something is time and space. Albert realized that time doesn't flow at the same rate for everyone. If you traveled very fast, close to the speed of light, time would actually slow down for you compared to someone standing still. Space would also contract in the direction you're moving. This means that two people moving at different speeds would experience time differently. For one person, a minute might pass, while for another, only a few seconds pass. Space and time aren't fixed and absolute like we always thought. They're flexible, relative, interconnected. Albert's fourth paper of 1905 contained the most famous equation in all of science: E equals mc squared. This simple equation says that energy, E, equals mass, m, times the speed of light, c, squared. What does this mean? It means that mass and energy are two forms of the same thing. A tiny amount of mass contains an enormous amount of energy. How enormous? Well, the speed of light is huge, and when you square it, multiply it by itself, it becomes incredibly huge. So even a small object, if you could convert all its mass to energy, would release tremendous power. This equation would later explain how the sun produces energy and would lead to the development of nuclear power and, unfortunately, nuclear weapons. Albert sent these 4 papers to a physics journal. He didn't know if anyone would care. He was just a patent clerk, after all, not a famous professor. But when the papers were published, the scientific world took notice. These ideas were brilliant, original, and profound. Still, recognition came slowly. Most physicists needed time to understand and accept these radical ideas. Albert remained at the patent office, waiting, hoping that someday his work would be fully appreciated. Climbing the ladder. By 1908, the scientific community began to realize that Albert Einstein was special. Universities started offering him positions. Finally, he could leave the patent office and become what he had always wanted to be, a professor of physics. His first teaching job was at the University of Zurich. It was a dream come true, though the salary wasn't great. But Albert didn't care much about money. He cared about having time and freedom to think and explore ideas. During these years, Albert continued developing his theories. He thought about gravity, that invisible force that keeps our feet on the ground and holds planets in orbit around the sun. According to Isaac Newton, who had lived 200 years earlier, gravity was a force that pulled objects toward each other. Newton's laws worked well for most situations, but Albert sensed something deeper was going on. He began working on what would become his greatest achievement, the general theory of relativity. Imagine the universe as a giant rubber sheet stretched out flat. Now place a heavy ball in the middle of the sheet. The ball creates a dip, a curve in the sheet. If you roll a smaller ball near the heavy one, it will curve toward it, following the slope created by the dip. Albert realized that this is how gravity works. Massive objects like the sun don't really pull on planets. Instead, they curve the fabric of space and time around them. Planets move in curved paths because they're following the curves in spacetime created by the sun's mass. This was a completely new way to think about gravity. It was beautiful, elegant, and strange. But was it true? Developing this theory took years of intense work. Albert had to learn complex mathematics he hadn't studied before. He made mistakes, hit dead ends, and sometimes felt like giving up. But he kept going, driven by his belief that he was onto something important. During this time, his personal life became difficult. His marriage to Mileva was falling apart. They had grown distant. Albert was consumed by his work, often distant and emotionally unavailable. Mileva felt lonely and neglected. They had a second son, Edouard, but even this couldn't save the marriage. Meanwhile, Albert's career was rising. He moved to Prague, then back to Zurich, and finally, in 1914, to Berlin, Germany. Berlin offered him a prestigious position with no teaching duties, just time to research. It was perfect for him, but it meant leaving Mileva and his sons behind in Zurich. The couple separated and eventually divorced. War and revelation. In 1914, just as Albert was settling into Berlin, World War I erupted. Europe was torn apart by conflict. Millions of young men went to war. Cities were destroyed. The world that Albert knew was falling into chaos. Albert was horrified by the war. Unlike many scientists who supported their governments and contributed to the war effort, Albert spoke out for peace. He signed petitions against the war. He refused to support German militarism, even though he was living in Germany and many people expected him to be patriotic. This took courage. In wartime, speaking against your own country can make you very unpopular, even dangerous. But Albert believed in humanity over nationalism. He saw scientists in different countries, people who had once collaborated and shared ideas, now refusing to talk to each other because their governments were at war. It made him sad and angry. Despite the chaos around him, Albert continued his work. In November 1915, he finally completed his general theory of relativity. The mathematics was incredibly complex, but the idea was beautiful. Gravity is the curvature of spacetime. But how could he prove it? Albert realized that his theory made predictions that differed slightly from Newton's theory. If he could test these predictions, he could show that his theory was correct. One prediction involved light. Albert calculated that light from distant stars should bend when it passes near the sun. The sun's mass curves spacetime, and light traveling through that curved spacetime should follow a curved path. Newton's theory also predicted some bending, but Einstein's theory predicted a larger amount. The problem was that you can't see stars near the sun during the day. The sun is too bright. The only time you can see stars near the sun is during a total solar eclipse, when the moon blocks the sun's light. A British astronomer named Arthur Eddington became interested in testing Einstein's theory. In 1919, there would be a total solar eclipse visible from certain parts of the world. Eddington organized expeditions to observe it and photograph the stars around the sun. The war had just ended. Here was a German scientist's theory being tested by British scientists, former enemies working together for science. It was a hopeful moment. The expeditions went to Africa and South America. They took photographs of the stars during the eclipse and compared them to photographs of the same stars taken at night when the sun wasn't nearby. If Einstein was right, the stars should appear in slightly different positions when photographed during the eclipse because their light was being bent by the sun. In November 1919, the results were announced. Einstein was right. The starlight had bent by almost exactly the amount he had predicted. The general theory of relativity was confirmed. Overnight, Albert Einstein became world famous. Newspapers around the globe ran headlines about the scientist who had overthrown Newton's centuries-old laws. People were fascinated by this wild-haired genius who had discovered that space and time could bend and warp. Albert was surprised by the attention. He had done the work because he was curious, because he wanted to understand the universe. He hadn't expected to become a celebrity. But now, everywhere he went, people recognized him. Photographers wanted his picture. Reporters wanted interviews. He received invitations from around the world. Fame and the Nobel Prize. The 1920s were a whirlwind for Albert. He traveled extensively, giving lectures to packed audiences. People who didn't understand the mathematics still wanted to hear him speak, to be in the presence of genius. He visited the United States for the first time in 1921. Americans were fascinated by him. Crowds gathered wherever he went. President Warren Harding invited him to the White House. He raised money for Jewish causes and for the establishment of Hebrew University in Jerusalem. Then, in 1922, Albert received news he had been waiting for. He had won the Nobel Prize in Physics. Interestingly, he didn't win it for his famous theory of relativity. The Nobel Committee wasn't quite ready to embrace such a radical idea. Instead, they gave him the prize for his work on the photoelectric effect, that first paper from his miracle year about light behaving like particles. Albert didn't attend the ceremony in Stockholm to accept the prize. He was traveling in Japan at the time. But the Nobel Prize confirmed what many already knew. Albert Einstein was one of the greatest scientists who had ever lived. Despite his fame, Albert remained humble about his achievements. He once said, "I have no special talents. I am only passionately curious." He believed that anyone could make discoveries if they asked questions and thought deeply. But he could also be playful about his fame. When people asked him complicated questions about relativity, he sometimes gave funny, simple answers. A reporter once asked him to explain relativity in one sentence. He said, "When you sit with a nice girl for 2 hours, it seems like 2 minutes. When you sit on a hot stove for 2 minutes, it seems like 2 hours. That's relativity." During these years, Albert remarried. His second wife was his cousin Elsa. She was kind and practical, and she helped manage the chaos of his public life, shielding him from constant interruptions so he could continue his work. Albert also remained close to his sons, though distance made it difficult. Hans Albert grew up to become an engineer like his grandfather. Sadly, Edouard developed mental health problems and spent much of his adult life in institutions. This caused Albert deep pain, though he struggled to express his emotions about it. The gathering storm. While Albert's scientific career flourished, dark clouds were gathering over Germany. In the early 1930s, the Nazi Party, led by Adolf Hitler, was rising to power. The Nazis promoted hatred toward Jewish people, blaming them for Germany's problems. Albert was Jewish, and he was also outspoken in his criticism of nationalism and militarism. This made him a target. The Nazis called his work Jewish physics and claimed it was worthless. They put his name on a list of enemies. There were even rumors that there was a price on his head. Albert saw what was coming. He had been planning a trip to the United States in late 1932. When he left Germany that December, he told Elsa to take a good look at their house. "You will never see it again," he said. He was right. In January 1933, Hitler became Chancellor of Germany. Albert was in California at the time. He immediately announced he would not return to Germany. He renounced his German citizenship. This was actually the second time he had done so. He had first renounced it as a young man to avoid military service. Albert became a refugee. The Nazis raided his house, confiscated his property, and burned his books. His German bank account was seized. If he had been in Germany, he might have been arrested or worse. But Albert was one of the lucky ones. He was famous, and institutions around the world wanted him. The newly created Institute for Advanced Study in Princeton, New Jersey, offered him a position. He accepted and made Princeton his new home. He arrived in America in October 1933. He would never leave. He became an American citizen in 1940, proud to be part of a country that had given him refuge. Life in Princeton. Princeton became Albert's final home. He lived in a modest white house on Mercer Street with Elsa, his secretary Helen Dukas, and his sister Maya. He walked to his office at the Institute each day, often lost in thought. People in Princeton grew accustomed to seeing the famous scientist wandering the streets, his hair wild and gray, often wearing a worn leather jacket and no socks. Yes, Albert famously hated wearing socks. He thought they were unnecessary and uncomfortable. Even when meeting important people, he often went sockless. It was one of his many quirks. Albert's life in Princeton followed a simple routine. He worked on physics problems in the morning, took a break for lunch, and often played his violin in the afternoon. He loved sailing, though he was reportedly terrible at it and often needed to be rescued when his boat capsized. He didn't care. He enjoyed being on the water, thinking. Despite his age, Albert continued working on physics. He became increasingly focused on finding a unified field theory, a single equation or set of equations that could explain all the forces of nature together: gravity, electromagnetism, and the newly discovered nuclear forces. He believed the universe had an underlying unity, and he wanted to find it. Many younger physicists thought he was chasing an impossible dream. Physics was moving in new directions: quantum mechanics, the study of the very small world of atoms and particles. Albert had contributed to quantum mechanics early on, but he became uncomfortable with its implications. Quantum mechanics said that at the smallest scales, reality is fundamentally uncertain. You can't know both the exact position and exact speed of a particle at the same time. Events at the quantum level are governed by probability, not certainty. There's randomness built into the fabric of nature. Albert didn't like this. He believed in a rational, ordered universe governed by laws. He famously said, "God does not play dice with the universe." He spent years trying to prove that quantum mechanics was incomplete, that there must be some deeper, more deterministic explanation. Most physicists disagreed with him. The evidence for quantum mechanics was overwhelming. But Albert stuck to his beliefs, continuing to search for the deeper truth he felt must exist. The war years. In August 1939, Albert did something that troubled him for the rest of his life. He signed a letter to President Franklin Roosevelt warning that Nazi Germany might be developing an atomic bomb. Remember Albert's equation, E equals mc squared? That equation showed that a tiny amount of matter could be converted into enormous energy. Scientists had recently discovered that splitting atoms, nuclear fission, could release that energy. If you could create a chain reaction, splitting many atoms at once, you could create a massive explosion. Albert and other scientists worried that Hitler's scientists were working on such a weapon. If the Nazis developed an atomic bomb first, they could win the war and impose their evil ideology on the world. The letter to Roosevelt helped start the Manhattan Project, America's secret program to build an atomic bomb. However, Albert himself didn't participate in the project. The U.S. government considered him a security risk because of his pacifist views and his history of speaking out against authority. Albert later said that signing that letter was the biggest mistake of his life. He had always been a pacifist, someone who believed in peace and opposed violence. The thought that his equation had helped create the most destructive weapon ever made haunted him. When the atomic bombs were dropped on Hiroshima and Nagasaki in August 1945, killing hundreds of thousands of people, Albert was devastated. He understood why it had been done, to end the war, but the human cost was terrible. After the war, Albert became an outspoken advocate for nuclear disarmament and world government. He argued that nations should give up some of their sovereignty to create a world authority that could prevent war. He knew that, in an age of nuclear weapons, another world war could mean the end of civilization. The gentle genius. Those who knew Albert in his later years described him as gentle, kind, and unpretentious. He received countless letters from people all over the world. Schoolchildren asking for help with homework, strangers sharing their personal problems, fellow scientists discussing ideas. Albert tried to answer as many letters as he could. He was patient with children, encouraging them to be curious and to think for themselves. To one young girl who wrote to him about her struggles with math, he replied with kindness and encouragement. He had a wonderful sense of humor. He loved jokes and wordplay. His office was cluttered with papers, books, and his beloved pipe. He often said that pipe smoking helped him think, making him calm and objective in his judgments. Despite his worldwide fame, Albert lived simply. He didn't care about fancy clothes, expensive possessions, or social status. He dressed casually, often in baggy pants and a sweater. His hair, which had become completely white, was perpetually messy. He became the iconic image of the absent-minded professor, though in reality, his mind was anything but absent. It was always working, always questioning. Music remained his refuge. He played violin almost daily, often performing chamber music with friends. Mozart was his favorite composer. He once said that while Beethoven created his music, Mozart's music was so pure and beautiful that it seemed simply to be, as if it had always existed and Mozart had merely discovered it. Albert also loved to sail. On warm days, he would take his small sailboat onto Lake Carnegie near Princeton. He wasn't a skilled sailor. He often ran aground or capsized, but he didn't mind. Being on the water, feeling the wind, gave him time to think and dream. Final years. In 1948, Albert's first wife, Maliva, died in Zurich. Despite their divorce and the years of distance, Albert felt the loss. She had been part of his early life, his early dreams. His own health was declining. He had always had stomach problems, and in 1948, doctors discovered he had an aortic aneurysm, a weakness in the main blood vessel from his heart. It was dangerous but inoperable. He could live with it for years or it could rupture at any time. Albert accepted this calmly. He had never feared death. He saw himself as part of the universe, a small part that would return to the whole when his time came. In his final years, he continued working, still searching for his unified theory. His desk was always covered with papers filled with equations. He knew he might not complete the work, but he kept trying. He also continued speaking out on issues he cared about. He opposed the nuclear arms race between the United States and the Soviet Union. He supported the civil rights movement in America, speaking out against racism. He declined an offer to become president of Israel, explaining that he was honored but was a scientist, not a politician. In April 1955, Albert felt severe abdominal pain. The aneurysm was leaking. He was taken to the hospital. Doctors said they could operate, but the surgery was risky, and even if it succeeded, he would only live a little longer. Albert refused. He had lived a full life. He had explored the mysteries he wanted to explore. He was ready. On April 18, 1955, at 1:15 in the morning, Albert Einstein died in his sleep. He was 76 years old. He had asked that his body be cremated and his ashes scattered secretly so that no place would become a shrine. He wanted to be remembered for his ideas, not worshipped at a grave. His final words were in German, spoken to a nurse who didn't understand the language. We will never know what he said. Perhaps they were thoughts about physics, or memories of his past, or simply comfort in his native tongue as he left the world. The legacy. Albert Einstein left behind more than scientific theories. He left behind a way of thinking, a way of seeing the world. His theories transformed physics. The special theory of relativity changed how we understand space, time, and motion. The general theory of relativity revealed that gravity is the curvature of space-time, explaining everything from falling apples to black holes to the expansion of the universe itself. His equation E equals mc squared unlocked the secret of the atom and led to nuclear power and, unfortunately, nuclear weapons. But beyond the equations and theories, Albert showed us the power of imagination and curiosity. He taught us that the most important questions often begin with "what if?" and "why?" He showed us that you don't need to be born a genius. You don't need expensive equipment or prestigious institutions. You need curiosity, persistence, and the courage to think differently. Albert did some of his greatest work in a patent office with nothing but paper and pen and his imagination. He also showed us that science and humanity aren't separate. Albert believed that knowledge should serve humanity, not harm it. He used his fame to speak for peace, for justice, for the freedom to think and question. He stood up against war, against racism, against anyone who tried to silence free thought. Today, more than half a century after his death, Albert Einstein remains one of the most recognized faces in the world. His image, the wild white hair, the kind eyes, the gentle smile, represents genius itself. But it also represents something more: wonder, curiosity, the joy of understanding. His theories are still used today. GPS satellites, the ones that help us navigate with our phones, have to account for Einstein's relativity because time runs slightly differently in orbit than on Earth. Scientists studying black holes, the birth of the universe, and the nature of space and time all build on Einstein's work. But perhaps his greatest legacy isn't any single discovery. It's the example he set. That one person, thinking deeply, asking questions, following curiosity wherever it leads, can change how humanity understands reality itself. A gentle conclusion. There's a photograph of Albert Einstein from late in his life. In it, he's sticking his tongue out at the camera, playful and impish, completely unbothered by the dignity expected of a great scientist. That photograph captures something essential about him. He never lost his childlike wonder, his playfulness, his joy in discovery. He once said, "The important thing is not to stop questioning. Curiosity has its own reason for existing. One cannot help but be in awe when contemplating the mysteries of eternity, of life, of the marvelous structure of reality. It is enough if one tries merely to comprehend a little of this mystery every day." This is Albert Einstein's true gift to us. Not just the equations, as important as they are, but the reminder that the universe is full of mysteries waiting to be discovered. That asking questions is valuable. That imagination is powerful. That wonder is wisdom. Every child who looks up at the stars and asks, "Why?" is following in Einstein's footsteps. Every person who questions what they're told, who thinks for themselves, who imagines new possibilities, they're carrying on his legacy. The universe is vast and strange and beautiful. It bends and curves in ways we can barely imagine. Time flows differently depending on how fast you move. Matter and energy are the same thing wearing different faces. These truths seem impossible, like magic, yet they're real, confirmed by countless experiments. Albert Einstein discovered these truths not with giant machines or laboratories, but with thought experiments, with imagination, with the courage to ask simple questions and follow them to their radical conclusions. So when you look at the night sky, remember Albert Einstein. Remember the boy who wondered about a compass needle. Remember the young man who dreamed of riding a beam of light. Remember the gentle, curious soul who showed us that the universe is far stranger and more wonderful than we ever imagined. And remember that you too can ask questions. You too can wonder. You too can imagine. Who knows what mysteries you might unlock, what discoveries you might make, what new understanding you might bring to the world. The universe is still full of secrets, still waiting for curious minds to explore it. It's waiting for people like you. As Albert Einstein himself once wrote, "The most beautiful thing we can experience is the mysterious. It is the source of all true art and science. He to whom this emotion is a stranger, who can no longer pause to wonder and stand wrapped in awe, is as good as dead. His eyes are closed. So keep your eyes open. Keep wondering. Keep asking why. And never, ever stop being curious about this strange, beautiful, mysterious universe we call home." That is the story of Albert Einstein. Not just a scientist, but a dreamer. a questioner, a reminder that imagination and curiosity can illuminate the deepest secrets of existence. His journey from a quiet boy in Germany to the most famous scientist in the world is a testament to the power of thinking differently, of following your questions wherever they lead, and of never losing your sense of wonder at the magnificent mystery of it all.